Phew. Okay. There we go. All right, looks like I'm ready to go. It's already streaming right now, so I checked that already. And yep, go ahead.
What's the best way to find all the screencasts?
Best way to find
The recordings of the lectures.
the recordings? I would say go to the announcements. Let me show you in just a little bit. Um, all right, so if you go to the announcements, let me max in my screen so this way. All right, cool. So if you look at the announcements, they all, every single one of the recording, there's an announcement for that one. So the link, should be right in it. So if you click on one of these, like this is from last time. So last time is a special one because I accidentally clicked the button on OBS and it paused and stopped the recording at about the 30-minute 35. So I had to kind of re-record the second part of the lecture on my own time. So hopefully I don't click accidentally click something like that anymore. Um, so does that answer your question?
Yeah.
Okay, great, excellent. So getting back to the announcement first. I just want to kind of repeat this, so students who are also in my 310 class has heard about this already. I sent you guys an announcement about IBM Z Day. It is a conference, organized by IBM. And the objective from IBM's perspective is to let the world know about their products and let their clients, their own engineers and whatnot to kind of network and talk about how to use the product, what is coming down the pike, and so on. But from your perspective, this is a great opportunity to look into a often neglected segment of employment. Because if you go to a four-year university, it can be Berkeley, can be UCLA, can be UC Davis, can be Sac State. Most professors, not all, but most professors would look at enterprise computing, which are also known as IBM mainframe computers, and they don't want anything to do with those computers, because they're considered like kind of obsolete and also kind of old-fashioned and so on and so forth. However, if you go to Wells Fargo, go to American Express, Walmart, the state of California, many, many departments of the state of California, and you ask, hey, if I know how to program in COBOL and I know how to work with an IBM mainframe computer, would I be able to get a job here? They'll just go like, okay, so we are going to show you how to get a job here because there's a shortage of people who can work with IBM enterprise computing, otherwise known as mainframe computers, but IBM does not like to use that term anymore because the term mainframe, okay, if you look up mainframe using a search engine, so let me see, there we go. So if you use a search engine and look up mainframe, what comes up, in a picture typically is something that is older or much older compared to what people use these days. So IBM doesn't like the image of the mainframe computer, but nonetheless, okay, getting back to the workshop. So today is mostly gone, because there's a workshop today from 9 a.m. However, the most important part starts at 5 p.m. today. So about half an hour after this class concludes, is a I wouldn't say it's just a panel because the first part is actually going to be a student, as a mentor to help explain how to participate in Z Student, which is a contest for people to kind of participate and you can earn micro badges. And then the second one, I think they will also talk about explore, as in X and implore, which is a self-paced exercise for people like yourself to kind of get some hands-on experience with how to work with enterprise computing. Yep.
Are they offering internships?
Internships. I don't think that is the case. So I don't think that is mentioned here. However, if you go to the discussion starting at 5 p.m., at the end of that discussion will be an open panel, so people can ask questions. That would be a great question to ask.
Who will be there besides you?
It'll be me. There is another person from SAC Hack. So they organize all the uh, hackathons around here. Um, One person is, let me see, is part of a society for Hispanic engineers. Um, but aside from these people, there's one person from IBM as well, and she is the organizer of this discussion, and she would definitely know, who would know about internships.
Okay.
Yep. Um, and on top of that, if you are interested in internships or being a student assistant, you can check with the state of California. Okay, let me show you guys here. So I know this has nothing to do with CISP440, but I think in the long run, this actually can benefit you. So if you search for um, state of California um, personnel, that's a personnel board. Let's see, the first one, yep, personnel board, and they have job postings, job posting. No, that's not what I want. Cal Careers, there we go. And you can look up your student or student assistant. So there you go. Lots of jobs, that has student assistant in it. Teaching assistant, graduate student assistant. So there are resources, that you can go to look for student assistant jobs. Um, is that kind of what you're looking for?
You answered my question. Thank you.
Okay. I think there might be people, tomorrow, there may be people who are coming from the state of California as well. So those people, should be able to answer that question in more details.
And so today they're going to have the IBM coordinator.
Yeah.
And tomorrow they're going to have people from the actual government who use these technologies.
Possibly, yeah. I think some of them will attend as attendees. So if you go to some of the workshops, you might be able to find, the people from state of California. If not, I know a few names. I can just, send it your way.
I already have a job.
That's okay. You can always transition. All right. So that's IBM Z-Day, and now we get back to the regularly scheduled program. All right, so the first thing I'm going to do is to go over just functions, because some of you probably have some questions. It's like, how do we figure this out? You never taught us about this thing. And then we are going to have a new assignment too. So the new assignment is called just function. It's worth 7 points. It is due on Monday at 3 p.m. Now, I do answer emails, and other forms of correspondence over the weekend. So you might want to get started like as soon as possible. So that way you have a chance to ask me questions before it is the due date. Yep.
Can you not have them as quiz format? Because I keep being nervous that it's going to submit by itself.
It will not submit by itself until the time when it is due.
But what if you accidentally click submit?
Well, I think we'll try not to have accidental things happen then. The quiz format is the only way I can ask different types of questions, like multiple choice and fill in the blanks, so I can mix and match those questions. There's no other way for Canvas to arrange to collect answers in an automated way. So that's why I have to choose to use the quiz format. All right, so let's get back to just functions, and we'll go over those answers. Yep.
Um, is there a way to have it so that it doesn't display the actual answers when you submit it until it is graded later? Because I've seen that instructors will sometimes have those multiple choice questions, and then you answer them, and then you submit,
Mm-hmm.
and then it doesn't tell you what the answers were or if you got them correct.
Oh yeah, I can definitely do that.
And then if you could do that, then you could allow for multiple attempts, right?
That is true.
So
That is true.
that's just a thought.
Well, okay, to a certain extent. Because if a question is multiple choice and I turn on that feature, even if I just let you know which question you're getting a 0 on, if it's a multiple choice, some people use I would call the infinite monkey approach. You just basically focus on one question at a time, try out all the answers, figure out which one is the right answer, jot it down. So I have had people doing that in the CISP310 labs. I can tell because they have like 16 submissions within an hour. So to address your question, I know you are not planning to do that, but if I enable that feature, then there will be people who might be doing that, which defeats the purpose of the assessment. Yep.
Can you just limit the submission to like create a folder or something?
I could, yes.
Yeah, seriously.
Okay, I'll consider that. That may be a good compromise. Just limit the number of submissions to a few, and turn on the feature, turn off the feature of showing you which one is the correct answer, but let people try again. So that's not a bad compromise. I'm okay with that. All right. So why is this over here? Okay, let me put it back here. All right. So let's work on just functions, which is something that you turned in earlier. Many of these questions need to be graded by hand, so that's why nobody should be getting a perfect score, even if you say, okay, but I think my answer is 100% right. That may be the case, but it cannot be automatically graded. All right, so this is the first question. X is ABC and Y is 1, 2, 3. What is the Cartesian product between those two? So, so the answer should be a set, which means it should be enclosed by curly braces. And then from here, it's just a listing of A1, A2. I mean, if you wrote a program to generate the answer, that's actually perfectly okay as well. You don't even have to turn in your code. Oh, by the way, the lazy person's approach is going to be, other than writing a program to do that, is just copy and paste, and then change all the A's to B's and C's. So C over here. I have a syntax or grammar checker turned on, and that's why you see all the yellow lines, because this is definitely not going to be grammatically correct. There we go. So that would be the answer. Any questions about this one? Okay. And the second question is referring to the definitions in the previous question. What is the cardinality? So that would be 9, because there are 9 items or 9 elements within the set, not 18. Okay. Now, so, I don't think anyone's going to answer 18, but if you count the number of things, you can say, but there are 18 things here because, we can see 3 A's, 3 B's, and 3 C's, and then 3 1, 3 2, and 3 B's. 3 1, 3 2, and 3 3s. But that would not be correct because we only count the number of 2 tuples within the set. So the correct answer is 9. Number 3 is fun. Enumerate all sets that can be considered functions using X as a domain, Y as a codomain. You can consider using a program to generate this answer. So that's kind of a clue that the answer may be a little bit on the tedious side. For this answer, use one line for each set that can be considered a function using X as a domain and Y as codomain. For example, and this is definitely not an answer, A14, A15, C20 as 2 tuples, they're all contained within a set. So the format is correct, but not the answer. All right, so how do we use a program to do all this? So I can show you the program, okay? I can actually show you a program written in plain C, to do all this. So let me go ahead and, I mean, are you guys interested? If no one is interested, I can just go like, yeah. Oh, no? Oh, okay, sure. So let me go ahead and write this code. And I did not have this pre-planned either, just like most of the things that I do. It is not pre-planned. It's the ADHD thing, you know. But I think I can do this. I think I can do this. So we'll just go make this program called at, I think it's Q3, right? All right, so we're going to write the program. And then we need double loop, okay? Because one loop to go through every element in the domain. And so that will be the outer loop. So for the outer loop, we'll just say, you know, char x to control the outer loop. So we'll say for x being initialized to a, x is less than or equal to c plus plus x. So now I have a way to iterate through the three elements of the domain. Are we good so far? All right. Actually, let's see, would that work? Go ahead.
I don't think it's necessary to loop through A, B, and C because for each function, you're only changing the numbers, the codomain that maps to each one.
Right.
So each function that you're going to enumerate will be A, B, C, so you can hard code that in.
Right, but instead of using hard coding, you know, the print statement to say this is, you know, what is A pairing up with, I still want a loop to do that. Do you see what I mean? So for printing purposes, I still need a loop. Okay, what about this? How about this? Okay, let's try to do it this way. If you are to encode the sets, you know, how would we do that? So we need a 3-tuple, you know, to control, you know, which element of one and the other one. Okay, so I can definitely see that. All right, so we're going to use a char array of co-mapped to, and it has 3 items. And now the question is, how do I iterate through every single one of those? So let me see. So we'll start with 111, 112, 121, and so on. So I think the outer loop, the outer loop would just do some counting because we are looking at base 3 numbers and we have to iterate through everything. Okay, so we can do that. So we can say unsigned I. For I is 0, I is less than or equal to 27 plus I. All right, so what I'm doing right now is there are exactly 27 maps, okay, you have 27 functions. And each one, you know, the first one is going to start with 111, and then the second one is 112, and then the third one is 113, and then 121, and so on. So we're talking about base 3 numbers, more or less, because they're not starting with 0, but that's just a little inconvenience, you know, in the whole thing. So once we have a particular integer I with value I can now determine, you know, what I need to put into map to. So mapped to bracket 0 is going to be 1 plus. Everything is going to be off by 1. So this is 1 plus. And then we need to extract the least significant digit. So that means I have to, let's see, what is the quickest way to do this? Okay, we'll use an unsigned J. So this is going to be I mod 3. So that takes care of the least significant digit. So after this, J gets divided by 3. and then mapped to bracket 1 is going to be 1 plus j mod 3, and then j is divided by 3 again, mapped to 2 is 1 plus j mod 3 again. All right, so at this point, I am guessing that this will generate all the zeros and, it's going to generate all the codomain elements, once we assume, the order is going to be A, B, and C. But I need to confirm this, so we'll go ahead and check this first. All right, so we get out of this, and we can do this later on. Return 0. All right, so I haven't really written a lot of code, but what I'm going to do here is I'm going to debug the program, just to confirm that I get the right values into mapped to. So the first time I get to here or here, I should get 0, 0, 0. The second time I should get 1, 0, 0, and then 2, 0, 0. So the third time, okay, let's see what we should be getting. When I equals to 3, 3 mod 3 is a 0. And then j is, oh, okay, I need to initialize j first. So forgot. So j is initialized to I first, then I can use j here. So j becomes 1, and then 1 mod 3 is 1, and then it's divided by 3 again, it becomes 0. So I think this should work.
And you have a straight void at the top.
Hmm?
You have a straight void at the top.
Yep. Thank you. All right. All right, so I'm going to show you guys how I write programs, because this is how I do it. Incrementally, I check on certain things first, and then we move on. So gcc-g-o q3q3.c. Still doesn't like it because I'm expected statement before close parentheses. Oh, because I is initialized here. Yep, so I is fine. J is initialized, inside the loop because it has a inside scope. All right, GDB Q3. This is a debugger. It looks really primitive, but it's really useful. So we're going to go run the program, and it did not stop on line 15. So I need a way for it to stop before it goes back to before it goes to the next iteration. So I will just give it something to do with, even though it's meaningless, because this gives me a line to stop at. So GCC, GDB, put a breakpoint on line 14, run the program. So now I'm on line 14, and I'm going to print out the array, which is mapped to 111. So that's all good. Continue the program, and then print map to again. It's 211. Okay, so things are flipped, but that's fine. It's not a problem. It should be 311 next, and then it should be 121. Then it should be 221, and then it should be 321. Then it should be the next one should be a 131. Yep, okay. So this way I have a way to basically iterate through 1, 2, 3 for each position, for the codomain. So now I got everything that I need in order to generate all the sets. All right, so get back to the program. So at the end of each of these iterations, now I just need something to print out everything. But as you said, we can just hard code it. So I'll go ahead and just hard code it. So it's going to be a printf. How many people were taught printf in CISP440 or 400? One person. Okay. Who did you take it from?
Anton Damos.
Okay. Damon Antos.
Damon Antos.
Close enough. Close enough. We won't tell him. All right. So here we just do the formatting. So we have a comma. This is a unsigned, so it's going to be. Oh, it's a char. Oh, it's a char. Okay. So what are we going to do? %C is a char. Okay. So we can do that. And then we have B char, C char. Close the curly brace, new line. And then we have to specify the characters. So the characters right now is going to be just 1, 2, and 3, which is not exactly what we want. So we have to add the ASCII code of 0 to each one. Or we can also do something here, because we can just basically say, let's just start with the ASCII code of 1. So now, if everything that we specify is going to be just an offset of the ASCII code of 1. So the next one is the ASCII code of 2, ASCII code of 3, and so on. And now we can supply all the elements of the array, which is mapped to bracket 0. And here we can just kind of fix the order too, but I'm not going to do that because it doesn't really, it just changes the ordering, but not the actual answer. So I think that should do it. What do you guys think?
Can you explain the mod C syntax?
Hmm?
What's the mod C syntax?
The %C? Okay, so in printf, it's kind of this is how people did things before we had C++. So before C++, printf is kind of the best way to print out something in a formatted way. That's what the F is stands for. It is formatted. It's print formatted. So the format means if everything is without a %, it's just printed verbatim. So whatever you specify within the double quotes is printed exactly the way you specify it. Percent means it is a placeholder. So, but what kind of thing is it holding the place for? That's what the character, that's what the C is for. It's a character. If you want to print it as an unsigned integer, it would be %U. If you want to print it as a integer signed, but you want to print it as decimal, it would be %D. If you want to print an integer as a hexadecimal, it would be %X, and so on. So it's a code, you have to kind of look it up, and it takes some time to memorize all of that stuff. So %C is basically saying we will specify the value to go into this placeholder later on within the arguments. So right now, all of this stuff here, all the ones in kind of magenta, they are printed as as is. But the %C is a placeholder, %C is a placeholder, %C is a placeholder. So then I specify the value that go into the placeholders. So map to 0 goes to the first %C, mapped to 1 goes to the second %C, and then mapped to 2 goes to the third %C. And then the \n is the line P character. This is how we terminate a line to start the next one. All right. Any other questions about this program? Okay. All right. Well, let's go ahead and give it a try. Let's give it a spin. Okay. I forgot to do a pound include. So pound include stdio.h. And then we'll try again. All right. So I'm somewhat confident this is going to do the trick. So we'll just run it. And that looks right to me. What do you guys think? So let's double check. Nope, something is not right. It didn't terminate correctly because I should only let it run up to 26 and not 27, because you can see the last item is a repetition of the first one. That's because I terminated the loop incorrectly. It should have said, I is less than 27 and not less than or equal to 27. Because if you look at 26, the base 3 representation of 26 is 222. That would be the last thing that we need. If you have not taken a class that talks about base conversion, this one is going to be a little bit mysterious. But I can post this solution so you guys can look at it and just kind of try to figure out how it works. And the use of a debugger is great for this sort of stuff. All right, so I'm going to run compile and run the program again. Oh, no, compile first. There we go. Run the program, and I'm going to send the output to the clipboard directly. So this way I can do the absolute laziest possible thing. So I can just paste it here. So I take the standard output of the program, type it, which means I send it to another process. But the other process, which is xclip-cell clip, is a Linux command to capture something from standard input and put it into the clipboard. So once the clipboard is populated by the actual output of the program, I just need to paste it into Canvas. So are we okay so far? All right. Yep.
Cardinality three cardinality three, made 2 and 1. Made sigma computer.
I cannot answer. There are questions that are very specific to your own.
Made 3, made
Okay,
Two.
I cannot talk about it now because, I need to kind of just show the answer to the whole class. So I cannot talk about your specific answer, not at this point. But there should be 27 of them, okay? There should be 27 sets. Each one should contain ABC as the first item of each two tuple, and then the second item should be all unique, within the 27 of these. All right, moving on. Question number 4, based on how X and Y are defined in the earlier questions, how many subsets of X Cartesian product with Y are not functions? In other words, what is F such that F is a subset of X and the Cartesian product of X and Y, and F is not a function using X as a domain and to Y, which is the codomain. All right, so we already know there are 27 of those subsets are actual functions. So to answer this question, what is left to do is to find out how many subsets are there when we are dealing with a set with how many elements. So what is the number of elements in the Cartesian product between X and Y? We answered that question earlier. There were 9 of them, right? So the question is now, how many subsets can we make from a set that has 9 elements? Now, what those 9 elements are really doesn't matter anymore. So that means, you can basically boil this whole thing down to a set that has integers from 0 to 8 close. Okay, and the only question is, how many subsets can you generate out of that particular set? Is that okay? So let me illustrate a particular technique. So let me illustrate the technique to you guys first. So let me fix the stylus so I can use Zernal. And this is one way to look at it. There may be other ways to look at it. Okay, I just changed my mind, but since I haven't said anything about the first approach, this would still be the first approach. All right, so let me move the Zernal screen so that you guys can see it. All right, there we go. All right, so I'm going to approach this from a recursive point of view. And you guys may be thinking, oh no, that makes it even worse. I don't want to deal with recursion. Well, it doesn't look like recursion. I promise it's not going to hurt. Okay, so if I just say, this is my set, and I ask you, how many subsets are there when this is the set? How many?
1.
1, because the empty set is its own subset, right? Okay, so now we say there's only 1 of those. And now we have a set that has a single element in it. And I ask, how many subsets can I generate out of this particular set?
2.
There'll be 2 because 0 can be present, 0 can be absent, right? And then I ask you the next one, which is now we have 2 elements in the set. How many subsets can I generate out of this particular set? 4. There are 4 of them because 0 can be present, 1 can be present, 0 can be absent, 1 can be present, 0 can be absent, the other way around, 0 can be present, 1 can be absent, or they can both be absent. Wait, hold on a second here. Doesn't that remind you of, like binary stuff? Yep, go ahead.
Never mind.
Oh, that's what you're about to say?
I'm gonna wait a second.
Oh, wait a second. Okay. Are we? Because it hasn't updated.
No, I know where the solution's going.
Oh, okay. I see. So we have 4. So what about the next one, which is 0, 1, 2? So, but this time we're not gonna spell out all the cases. Instead, we'll think about this in a much more systematic way. Okay, in a much more systematic way in the terms of this thing is really this thing unioned with this thing here, except they don't overlap, right? We already know there are 4 subsets with 0, 1 as a set. So that means if I just add one more element to the whole mix, we can now say, okay, there's one case where 2 is absent, and then we just reuse all the subsets of 0, 1. And then we'll assume that 2 is present, but then we'll reuse all the subsets of 0, 1. Yep.
Isn't there a way that we can just say that for each element in the set, it's just to a power of 2?
Yes, but I'm trying to explain why that is the case.
Okay.
Yep. So there are 8 subsets in this case. The 8 is because we have 3 things in it. Each one can be present or absent, independent to the other 2. So that means we are really asking about if I were to generate a truth table with 3 independent variables, how many rows do we have? So in this case, now if I use T to mean it is present and false to mean it is absent, it's going to look like this. False, 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 true, 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 false, false, true, true, false, false, true, true, and then we have false, true, false, true, false, true, false, true. That enumerates all the possible ways where one can be absent but the other one is present and so on. Does that make sense? Because we are looking at the presence of an element as a subset. Are we good or not? We good? Okay. So that is why we have an answer of 8, because each element can be present or absent, and hence the base of 2. But why is it raised to the power of 3? Because there are 3 of these. When the first one is false, the second one can also be false or true. When the first 2 are false, the third one can be false or true. So every time we add a new item into the set, we have to multiply the total number of subsets by 2. So that means when you have 9 items in the set, how many subsets can we generate? What is the number of subsets? Which is 512, exactly. But we don't want 512 as the answer, because 512 is the number of possible subsets from the Cartesian product between x and y. But we know out of those 512, 27 are valid functions. So we have to subtract 27 from this first. So we have a 5, there's a borrow of 1, so we have 485 of those subsets. They are not functions. So let me just kind of write it down. Oops. All right, 485. If my math is right, okay, it's looks correct to me. Yeah, because the other one is 27. I'm just double checking my math because sometimes I make mistakes with that kind of stuff. All right, so let's check, whether this one I cannot grade. It cannot be automatically graded. This one can. This one cannot, and then the last one can. So there we go. So the last one was not supposed to be a tedious, yes, I really am going to enumerate every single possible subset. It is supposed to be a thought exercise. Is that okay? All right. So with that said, I am going to move on and kind of continue what we were talking about from last time. So last time we were, okay, let's go back to the Aleph null module. So last time we talked about the G function. So let me just kind of scroll to the right place. Okay, so last time we talked about the G function, which is here. And we figure out the G function by observing characteristics of how we assign natural numbers to each pixel in the two-dimensional space. So we noticed, how the bottom row or row 0 got its value because it would go from 0, 1, and then it go from 1 to 3, and then it goes from 3 to what? 1, 3, and then 6, and so on. So we notice that there's a pattern, and we use that pattern to figure out the values of everything on row 0, and that turns out to be this equation. Okay, let me zoom out one step so we can see it. So if you're talking about something on row 0, it's going to have a pattern of x0, where x is the column number, and we figure out it is just a summation of 0 plus 1 all the way up to x, and then we figure out, oh, that's a closed form. It is x times x plus 1 divided by 2. But once we figure out the natural number assigned to something on row 0, we just have to add the y coordinate to figure out a pixel that is somewhere else. Okay, so that's why we end up with this equation, which is just adding the y coordinate to the whole thing. Now this part here is x plus y, because we also noticed that every pixel on the same diagonal line has the same sum when you add up the x and the y coordinate. So that's why we have x plus y, and then we have x plus y plus 1, because in the original equation, there's an x plus 1 over here, divided by 2, and then to add the y coordinate to get to that one pixel along the diagonal line. So are we still are you guys recalling, this discussion from Monday? Okay, very good. So now we want to reverse the process. In other words, I'm going to give you a natural number, and you have to help figure out which pixel is getting that natural number. So we are reversing the process. To reverse the process, it's actually a little bit harder. All right, so our new challenge is to find x and y so that for a given natural number n, such that g of xy equals to n, we want to figure out what the x and the y are given the n. In other words, we are looking for g inverse. So are we understanding what we are trying to solve? What is the problem that we are trying to solve here? Okay. To find the inverse function, we first have to find the diagonal line. In other words, once we find the diagonal line, it's pretty easy. Okay. Then the position of the pixel on the diagonal line, that would be the second step. Symbolically, given that g inverse of n equals to xy, we are trying to find a w such that w equals to x plus y, because w0 is the base of the diagonal line of the xy, of the pixel that we want. Is that statement understood or not? Let me give you a pictorial representation. I think that should help. So let's move to that. All right. So what we are dealing with here is we have this space. I have a particular natural number. Okay, we'll say n. We don't know which pixel is getting the value of n. We don't know. But instead of trying to get to the pixel directly, the first thing we want to do is to find which diagonal line contains the pixel that we want. So now, so let's say it is this particular pixel. So what we want to do now is to say, okay, so if we look at this diagonal line, where is it? Where's the intercept with the x-axis? That's the first question that we want to find. So if the pixel has the coordinate of xy, then the base of the diagonal line is going to have the coordinate of x plus y 0. Is that okay? Does everybody understand why that is the case? If the pixel that contains the natural number of n is xy, then at the base of the diagonal line that contains the pixel that I'm trying to find, the base is going to have the coordinate of x plus y comma 0. And that has to do with every single pixel along a diagonal line has the same sum when you add up the x and the y of the pixels. Are we good so far? All right. And for convenience, instead of saying x plus y all the time, instead of calling this x plus y, I just call it w. So w is nothing more than an abbreviation of x plus y. Are we good? Are we okay so far? So we want to find w. So the way we find w is to say, okay. So the way we find w is to set up this equation. So g of w0 is definitely w times w plus 1, the whole thing divided by 2, because the y coordinate in this case is a 0. Is that okay? So we are basically just reusing g that we derived from Monday, and then we say, okay, so we instead of trying to find x comma y, we'll try to find w0 first. So we know this has to be less than or equal to n. Why do we know that? We know w0 is at the base of the diagonal line that contains the coordinate, that contains the pixel xy. So how do I know that this value, g of w0, has to be less than or equal to n? Because when we go up the diagonal line, we increment the natural number being assigned to the pixels. Is that okay?
What is n? What is n in this? What is n?
What is n? N is the natural number that is given to you. So I can say, okay, I'll give you a natural number, say 31,617. And your job is to find out which pixel has that natural number assigned to it. So that's n. So w is x plus y. We have not resolved, okay? We don't know what w is at this point. But we know that w is the sum of x and y. Is that okay? All right. So now we have an inequality. Well, it's an inequality, but it doesn't stop me from using algebra. So the algebra that I use here should be fairly elementary. From here to here, I'm simply separating the w squared onto its own fraction. And then we have the w, because we have this w distributed to the 1, and then the whole thing divided by 2. So we have a w divided by 2. That whole thing is less than or equal to n. And then to move the n, I subtract n from both sides. And I just use 0.5 instead of divided by 2. Okay, no big deal. So now we have 0.5 w squared plus 0.5 w minus n. And the whole thing has to be less than or equal to 0. What does that look like to you? And then I multiply both sides by 2, okay? Yeah, but what does it look like to you?
Quadratic.
Looks like a quadratic, except instead of an equality, it is an inequality, right? Okay. So you just pretend that it is an equality, and you want to solve for this w. How do we solve for w? The quadratic equation. Now, believe it or not, I cannot remember the quadratic equation. So I had to look it up. It's like, okay. All right, so now, but if I plug in the values, okay, if I plug in the coefficient of 1 for w squared, the coefficient of 1 for w, and the coefficient of -2 for -2n for what we usually know as c, which is the coefficient of the constant of the 1, we end up with this equation here. Are we good so far? Does everybody understand that I'm just substituting the a, b, and the c typically of the quadratic equation with the values of a, b, and c from the so-called equation? Are we good so far? All right. So what do we get? Well, normally we get 2 roots, right? Because that's the whole point of the quadratic equation. It gives you 2 roots. But we only want to focus on one, because the one that is negative cannot be the answer. Because w is x plus y. What is x? X has to be a natural number. What is y? Y also has to be a natural number, which means both of them are greater than or equal to 0. The sum of x and y cannot be less than 0, cannot be negative. So that means I can focus on just the -1 plus the square root of blah, 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 because the other one has got to be negative. Are we good? So if we focus on the positive one, then we end up with something like this. But why do I put a floor symbol here? What happens if I do not have the floor symbol? What is w going to look like? What does it look like?
It could be any number along the x-axis that, like, leading up to the diagonal you're looking for. It's
guaranteed to be a real number, but it can be irrational.
Okay.
So in math term, it can be an irrational number, and an irrational number is definitely not going to be a natural number. We know that w has to be a natural number because it is a sum of 2 natural numbers. So by putting the floor symbol here, I'm saying, well, okay, this actual quantity here may not be a natural number. We'll just kind of take a step down to the next available natural number. Why do I take a step down instead of taking a step up? It has to do with the direction of the inequality. Because the inequality says this expression has to be less than or equal to 0. If I solve for w without the floor, I end up with the exact value of 0. So how do I make it so that it is guaranteed to be just less than or equal to, and then w itself is guaranteed to be a natural number? Take the floor, not the ceiling. Because if we take the ceiling, that means the value is going to be greater than or equal to whatever I'm taking the ceiling of, which also means if you plug this in, you can see that coefficient of w squared is positive. The coefficient of w is also positive. So if w itself is increased, that means instead of an inequality, I'm going to have a greater than or equal to, which is not what I want. I want something that is less than or equal to, so that's why I need to take a step down to the next available natural number next to this irrational number. Are we good so far? Okay, so we have a way to find w now. So once we find w, what do we do next? It would be easy, because let me show you the graph first. So if I show you the picture, if I find w, that means I find the value at the base of the diagonal line. I know the value of this guy already. So what do I need to do next? This is n. This particular pixel, I don't know where it is along the diagonal line, but I know it has a natural number of n. I know this thing has a natural number of, because I know w, so now I know it's w times w plus 1, the whole thing divided by 2, right? So the difference, the delta y, okay, the difference in terms of the y coordinate between this pixel, xy, and at the base, x plus y 0, is going to be n minus w times w plus 1, the whole thing divided by 2. Because that difference is telling me how many steps I need to traverse this way to get to the pixel that I need to get to. Does that make sense? Okay. So if I were to write down the numbers here, okay, this thing is going to have a value. The natural number is going to be w times w plus 1, the whole thing divided by 2. So that means this thing here is going to have the difference, this difference here, is going to be n minus w times w plus 1, the whole thing divided by 2. That is how much vertical distance is between row 0 and where the pixel is supposed to be at. Are we good so far? So now we switch back to the slide. So the slide says basically exactly the same thing. Oops. I have to remember because when I move my mouse pointer, it changes the focus. So now we know what the y is. Once we know what the y is, we know what the x is, because after all, w by definition is x plus y. So once we know w and we know y, we just have to say, what is w minus y? Because that is what x is. So now we have a way to find both the x and the y coordinate of the pixel that has n as the natural number assigned to it. So we're understanding the process, kind of, okay? So the rest of this slide is really just kind of tweaking things so it looks nice. So I define a function called w, excuse me. So wn, w of n is defined to be just the term that we saw earlier, except now n is a parameter. So we can just say w of something. And then after we plug in everything and do all the substitutions, G inverse of n becomes a 2-tuple. The first item, which is indicating the x coordinate, turns out to be this. And then the second item being the y coordinate turns out to be something like that. That's it. That's our inverse function. So G is a bijective function. We know the inverse function has to exist. And this is how we express the inverse function of G. Are you guys convinced, or do you want to test it out a little bit? Yep.
What if n is 0?
What if n is 0? Well, let's try to figure it out. So if n is 0, then we have 8 times 0 plus 1, and then we take the square root of that, which is just 1, right? The square root of 1 is 1. So we have 1 minus 1, which is a 0. 0 divided by 2 is 0. The floor of 0 is also 0, right? So Wn is, W of 0 is 0. So we plug that into here. So we have 0 times 0 plus 3, and then the whole thing divided by 2. Let's see. Right. So 3 divided by 2 is that would be, yep, oh yeah, right, it will be 0 divided by 2 because there's a multiplication here. So here's a 0 times something, divided, the whole thing divided by 2, so that would be 0, thank you. And then we have 0 minus n, but guess what? N is also 0. So we have 0 minus 0, so the x coordinate is going to be 0. On the other side, we have 0 minus, this is also going to be 0. So we have 0 comma 0 as the coordinate of the pixel that has the natural number of 0 assigned to it.
What was it, x 3 halves?
Oh, there's another parentheses.
Oh.
Yeah, so there's the plus 3